In the second unit of algebra is exponential functions. We spent tons of time working on linear, the y equals mx plus b. And now we're going to spend a little bit of time on exponential functions. And so instead of the y equals mx plus b, this is going to be our new focus. Y equals ab to the x power. We're going to be owning this equation for the next few weeks. And there's some rules or sort of some insight about this equation that can be helpful to us. So there's kind of some issues that happen, and one of them is about a. This value a cannot be 0. Another issue is b, and something that we need to know about b is that it can't be 1. And the last kind of a strange little issue here is also about b, and b has to be bigger than 0, meaning it can't be negative. So the first thing we're going to take a look at is checking out the difference that we can see in tables between linear and exponential. So this is an example of a linear function. So as we write this one down and see, the x has a pattern of +1, +1, +1, which is why I wrote +1 right here. And then as we look at y, I see it's +2, +2, +2, which is why I wrote +2 right here. This should look familiar to us because we had been working on slope for a very long time. Change in y, the rise, over the change in x, or the run. So since this has slope, or a constant rate, this is linear. I know that this function is linear. And again, for us, that's review. We've been taking a look at those for a while. So we wrote this down here so we can see the difference between linear and exponential. So now let's take a look at an exponential function. So as we look at the t-table, we can still see that our values for x increase by +1, +1, +1. So that's why I wrote a +1 right here. But this time, as I look at my y values, notice what happens. If I go from 4 to 8, I could add 4. But if I take 8 plus 4, I definitely don't get 16. There's a new pattern happening this time. And if you look further, you'll see it's times 2. So times 2, times 2, times 2. And since that is not a constant rate of change, a constant rate of change happens when I'm adding or subtracting. So since I'm multiplying this time, that's when I can see that it's an exponential function. Since that y is being multiplied, this is exponential. So that's what it looks like in a table. Now we're going to head on to some of our graphs. And right before we do that, I just want a quick review of domain and range. So I know you've had this and seen this before in science and in math. But if you ever see the word domain, they're talking about any of the x values. And if you see the word range when we're graphing, that's talking about the y values. So just a quick review of that. Now the next thing we're going to take a look at are two graphs. And we're going to sketch these two graphs, again, with this standard equation of y equals ab to the x power. And on this side of my sheet, I'm going to look at what a graph looks like if b is smaller than 1. So this little guy right here, this b, excuse me, not smaller, bigger, if b is larger than 1. Okay, so if b is bigger than 1, this is what my graph looks like. There are these little swoops. And notice in this graph happens when a is positive. There's a swoosh that goes up real fast here. And then this swoosh is going down whenever a is negative. Okay, so here's my two swooshes. If b is bigger than 1, and a is positive, or a is negative. Okay, so again, we're getting out of the linear and getting into some of these curves, starting to see what curves look like in math. Now in the next one, again, the same setup, we still have y equals ab to the x power. This time, we're going to check out when b is between 1 and 0, meaning that it could look like a decimal or a fraction. the swoosh is going to look a little bit different. So when that b is between 1 and 0, or a decimal or a fraction, the swooshes look a little different. I am looking at the one if a is positive, this is what that swoosh looks like. And if a is negative, this is what it looks like. So notice the difference between the two. On this side, my swoosh is starting low and increasing high. And on this guy, it's starting high and going low. So you can kind of see the difference between the two.